My invisible friends, hello, and welcome back to our series on electrical and computer engineering. Our conversation tonight is about evil branches, supernodes, and the modified nodal analysis MNA. What is an evil branch? You well know that my premise is that humans never forget ridiculous or cruel stuff. As you have noticed, I have named branches that have only a V source in them as evil branches, but they are simply V branches, right? Why do I call them evil? Because they make us work more, because they introduced one additional unknown, which is its current, and one additional equation to the solution of the circuit. That is why more work, evil branches. But today we shall see that a V branch, in reality, those evil branches, are a blessing in disguise if we know how to take advantage of the opportunity they give us. The reference node anywhere, right? Yeah, formally the reference node can be anywhere in the circuit. It is your choice, it's arbitrary, but you pick it up out of conveniency, right? Convenient how? Well, you can pick the node that has the most number of branches arriving in it so that you don't have to write that massive KCL equation. Another one, if we choose one node of an evil branch as the reference, the voltage in the other node is not an unknown anymore. So we don't need to write a KCL equation for that other node. And we don't need to write an evil equation either for the evil branch. Instead of adding one equation, we end up removing two equations from the system. Nice, eh? Let's have an example of choosing the reference node elsewhere, like this one. We need to solve that circuit. There is an evil branch here, 7 volts. But I go ahead and I choose the reference at the bottom, and nodes 1, 2, and 3, like so. To solve this circuit like so, we would end writing 4 equations: KCL for node 1, KCL for node 2, KCL for node 3, and of course the evil equation, which is V2 is V3 plus 7 volts. We would have 4 equations and 4 unknowns: V1, V2, V3, and I evil, the current in the evil branch. But there is a wiser choice for the reference, as we said before. Instead of choosing that anywhere, I go ahead and I pick one of the 2 nodes of an evil branch, like here. If I pick that as the reference, the voltage of the other node is going to be known. It's going to be 7 volts. If I picked this node instead as my reference, then the one on the right would have been negative 7 volts. Either option works just fine. Apart from those 2, nodes 1 and 2, branch currents, and we write the equations. How many? Only 2. Let's say I do not care for computing the value of the evil current up front. I write a KCL equation for node 1, currents going in, the one at the top, 12 minus V1 over 2, that's right, plus 7 minus V1 over 2, and that's equal to the current leaving the node V1 minus V2 over 5. And KCL for node 2, currents arriving in node 2, those are 2 currents. A V1 minus V2 over 5, that is the first one, and then the one in the middle branch, 7 minus V2 over 3, and the current leaving the node is only 1 V2 divided by 5. 2 equations, 2 unknowns, we solve for them and we find V1 and V2. And what if we want the current in the evil branch? Now that we have V1 and V2, now we compute this I evil current as the sum of this current in this branch and that current in the vertical branch. We compute it like that: 7 minus V1, we know V1, divided by 2. 7 minus V2, we know V2, divided by 3. And that's how we do that. What about supernodes, which is the name of this movie? When an evil branch is not touching the reference node, which is often the case, you can turn it into a supernode. And you can cut the number of MNA equations by 2 as well. Draw a Gauss surface around the evil branch, including its 2 nodes of connection. And then highlight the unknown voltage of one of the two nodes of that supernode and give it a name. I'm going to call that, let's say, V sub X. And then you label the voltage of the other node either as Vx plus the value of the source or Vx minus the value of the source, depending on how you connected the source in the circuit. And then finally you write a single KCL equation for the entire Gauss surface or supernode. I'll show you how. The same example as before. The reference at the bottom. We spy one evil branch that we will turn into a supernode with a Gauss surface, this one, including the two nodes on the left and the right. Fine. Label with an unknown one of the two nodes. I chose this one, that is Vp, an unknown value. Automatically the voltage of the other node is going to be not another independent unknown. The voltage here is going to be Vp minus 7. Right, if I had chosen to label the one on the right as Vp, then the voltage on the left would be Vp plus 7. Absolutely. We are ready. Nodes 1, only one. Yeah, apart from the supernode branch currents, and we write KCL for node 1. Currents arriving into node 1, only the one on the top. Let's review that carefully. Voltage of the origin, Vp minus 7, minus voltage of the destination V1, plus the value of the helping voltage source 12 divided by 2, the resistance in the RB branch. That's equal to currents leaving the node, V1 minus Vp over 2 plus V1 divided by 3 plus 2. And now the KCL equation you had been waiting for, the KCL equation for the supernode. The supernode includes 1, 2, 3, and 4 currents. Only one of them is arriving in the supernode, the one from the left, V1 minus Vp over 2. The other 3 currents are leaving the supernode, the one here at the bottom, Vp divided by 3 ohms. This term over here. This other term is Vp minus 7 divided by 5 ohms. And the one on the top, we already know what that is a current in an RV branch, voltage of the origin Vp minus 7, minus voltage of the destination V1, plus the value of the helping source 12 divided by their resistance in the branch. 2 equations and 2 unknowns. We solve for them instead of having 4 equations and 4 unknowns. And that's how that works. That's how you declare and take advantage of an evil branch as a supernode. But there is a question pending. Does this work with dependent evil branches? Yes, it does. Show me? Sure. I will leave you with this example. Check it out. In this circuit, the reference is at the bottom, but there is an evil branch up here with a dependent V source. So I have declared these evil branches as a supernode with that Gauss surface. I've identified the node on the top right as the unknown Vp, and then automatically the other voltage is Vp plus the value of the source, 4 times Ix in this case. The equations are there for your perusal. And with that, my friends, thank you very much for watching, and I hope to see you again in our next video.